All right, let's take a look at our first lesson, chapter 3, lesson 3.1, lines and angles. So we're going to talk about lines and the fact that not all lines and planes intersect. This whole chapter is about lines. So as you look here, let's talk about two lines that don't intersect. Now, those are called parallel lines. Parallel lines are coplanar lines, which means they're in the same plane, and they do not intersect. So the symbol with two vertical bars means is parallel to. So for example, we have AE is parallel to BF, and AD is parallel to BC. So if we look over here, you'll see that AE is in the front, BF is also in the front. We can draw a plane here between these two. So therefore they're in the same plane, they're parallel. Same with AD and BC. So let's look at the next type of lines. These are going to be called skew lines. Okay, skew lines are lines that they're not parallel, but they also don't intersect. Okay, so they're non-coplanar, which means they're not in the same plane. Lines like AB, the ones in blue here, this one and CG are not ever going to intersect. Okay, they're not in the same plane. You can't draw a plane between these two because one's running this way, one is running this way. One way to think about it is, if you're driving on the highway, you cross a bridge, or you have a bridge go over you. Okay, that's an example of skew lines. The highway that you're on is one line, and the bridge that goes across you is another line. You're not ever going to intersect, but you also do not have, so they won't intersect, but they're also not in the same plane. And parallel planes. Parallel planes are planes that just don't intersect. Okay, think of it like a box. The top of the box and the bottom of the box. Those are two planes that don't intersect. Front and the back of the box, the right and the left. So the symbols here, what we do is we have to write plane, A, B, C, D. And a lot of times, remember, you only have to have 3 letters. But you can put 4 or 5. What they tend to do is name all 4 points of that face. So A, B, C, D. That's the entire top face. Sometimes that helps us easily identify it. And plane E, F, G, H. That'd be the bottom face. Those are parallel. We just put the parallel symbols. So let's take a look at our next example here. Which segments are parallel to AB? So if we look here, we're going to name all the segments that are parallel to AB. Well, AB is this line right here. Okay, so we're looking for all the ones that are parallel. As we look at here, we're going to go through and we're going to look at all the ones that are in the same plane that run the same direction. So as we look here, we have EF. These are in the left face here, they're in the same plane. They are parallel. We know CD is also parallel. Same plane here. The one that a lot of people forget about is GH. Okay? Because these are in the same plane, because we can draw a plane that goes from this corner, this diagonal to this diagonal. And so therefore this becomes the same plane. They're in the same plane. They're parallel to each other. Okay, so if you can draw a plane to another line, then you can say it's parallel to it. It's in the same plane. So as we write these down, we would say that EF, we would have CD, and we would have GH. So these are 3 planes that would be parallel to AB. All right, so let's look at the next question, part B. Which segments are skew to CD? Well, skew, once again, remember, it means it's not in the same plane. They're not going to intersect. So here's CD. So now let's go mark all the ones that would not intersect but not in the same plane. Now remember, they should not, the segment should not end in a D or a C. It means they do intersect. That means that we cannot say BC or AD. So let's look here. This line right here, AE, this is a line that would not intersect, not in the same plane. Therefore, BF would be the same thing. You couldn't include CG or DH because they would intersect at C and D. So the other planes would be ones that would go in the cross it here, kind of like the road and the bridge, which would be these two here. EF would be parallel to it because we could draw that diagonal plane. And so an AB would be parallel to it. So as we write these down here, we're going to write down all of them. AE, BF, FG, and EH. So those are all of our planes, all of our lines that are segments that are skewed to CD. All right, what are two pair of parallel planes? So remember, when you write these down, put the planes, write the word plane, identify it, put parallel to the other plane. So do this now, pause your video, and come back and answer these last two questions, and we'll come back and talk about those. All right, so what I'm looking at here, you have actually three pair of parallel planes. You have the front and back, you have the left and right, and we have the top and bottom. So I picked the top and bottom, A, B, C, D, and E, F, G, H. Then I chose A, D, H, E with the front and the back. You have B, C, G, F. You could have also had A, B, F, E, and D, C, G, H. So now let's look at two segments that are parallel to the plane BCGF. The plane BCGF is our back face, which means that any segment in the front plane, because this plane is parallel to it, would be parallel to this plane. So that could be segment AE, DH, AD, and EH. When a line intersects two or more lines, the angles formed at the intersection points create special angle pairs. This is what we're going to focus a lot on here in the next few lessons. The transversal. The transversal is the line that's going to intersect two other lines. It could be two lines, it can be 3, 4, there's an unlimited number of lines it can intersect. That transversal, it's going to intersect these lines and create 4 angles at each intersection. So it intersects 2 lines, we're going to have 8 angles. 3 lines, we'll have 12 angles. 4, 16. So the T is what we call, line T here is the transversal. Now, if you notice here, we got lines L and line M. Intersects these two. Anything in between line L and line M we'll call the interior angles. Anything on the outside we'll call the exterior angles. So notice that 3, 4, 5, and 6 lie between L and M, so those are going to be our interior angles. Angles 1, 2, 7, and 8 lie outside line L and M, and they are called our exterior angles. Now for each set of angles, they're going to create a special relationship. Now one thing that we've already talked about before is that you need to recognize vertical angles. So 1 and 3 are vertical, 2 and 4 are vertical, 5 and 7, 6 and 8 are vertical angles. We know those are congruent. And also, just by looking at this picture, we know that 2 and 3 form a linear pair. Same with 1 and 2, 1 and 4, 3 and 4. So linear pair means they're going to add up to 180, so they are supplementary. So your angles, anytime you have a transversal intersecting 2 lines, we're going to have a pair of vertical angles, and we're going to have several pairs of linear pairs, supplementary angles. So angles are either going to be congruent or they're going to be supplementary. So let's look at our first set of special angle pairs. First one is alternate interior angles. These are non-adjacent interior angles that lie on the opposite sides of the transversal. The first word refers to how they relate to the transversal. Alternating sides, like opposite sides. Interior refers to how they relate to the 2 lines. So 3 and 5 would be examples of alternate interior angles, same with 4 and 6. So these are our 2 sets of alternate interior angles. Now let's look at the next set of special angle pairs, and that's same side interior angles. These are on the interior of the two lines, and they're on the same side of the transversal. So the same side and interior. So that's going to be angles 4 and 5 and 3 and 6. These two in here, same side of the transversal, inside of the two lines. All right, let's look at our next pair. Corresponding angles. This is the only one that has 4 angle pairs, special angle pairs. These are going to be on the same side of the transversal and in corresponding position. Now, understanding what corresponding position means, that means they kind of relate. They're in the same type of position. They correspond to one another. So example of this is like if you look at your 4 angles here, 1, 2, 3, and 4. 1 is in the upper left-hand corner. It matches up with 5. It's also in the upper left-hand corner of these 4 angles. So therefore we say these are corresponding angles. Same side of the transversal, in corresponding position. 2 is in the upper right, 6 is in the upper right. They're corresponding angles. 3 and 7, lower right, corresponding. And then 4 and 8 are both in the lower left of their 4 angles. So those are corresponding. They match up together. So corresponding angles are on the same side of the transversal, and they're in corresponding position. Now the last pair is the alternate exterior. Alternating sides of the transversal and on the exterior of the two lines. So 1 and 7, alternate exterior. 2 and 8, alternate exterior. They're on opposite sides of the transversal and outside the two lines. So that's 1 and 7 and 2 and 8. All right, let's look at example 2. Which is a pair of alternate interior angles? Is it 1 and 3, 6 and 7, 2 and 6, and 4 and 8? If you marked 2 and 6, then you got it right. 2 and 6 was the correct answer. These are alternate interior angles, and that's kind of what we'll use to abbreviate. So let's see, what is angle 1 and 3? 1 and 3 is going to be corresponding angles. So there's corresponding angles. That's kind of our abbreviation, CORR. 6 and 7, they're on the same side of the transversal. They're both on the inside, so this is same side interior. Okay, and then 4 and 8. 4 and 8 are on the alternate sides of the transversal. They're both on the outside, so this is alternate exterior angles. So, down here, what are 3 other pairs of corresponding angles? We've already named one, like here at A, 1 and 3. So, fill these out, write down the other 3 pairs, and come back and see how you did. All right, you should have gotten 2 and 4, 7 and 5, and 8 and 6. So hopefully you have a good understanding of what different types of special angle pairs there are in these 8 angles. Let's take a look at our last example. The photo show in Royal Ontario Museum in Toronto, Canada. What are angles 2 and 4? So 2 is right here, 4 is right here. These are on opposite sides of the transversal. This line right here, these are 2 lines. This is our transversal. So we'd say they're alternate something, and they are inside the 2 lines, so that would be alternate interior angles. So these would be alternate interior angles. So let's see what the last one would be. What are measures of angles 1 and 3? Angle 1 is here, angle 3 is here. And if you answered same side interior, okay, then you have to make sure you're wrong, because you got to double check here. They're on the same side, but one's on the inside, one's on the outside. They're in the corresponding positions. This is corresponding angles. This is the one that gives most people problems, is the same side and corresponding. Okay, corresponding, one's going to be on the outside, one's going to be on the inside. They're in corresponding position. same side interior are both on the inside. All right, so that concludes lesson 3.1.